In this lesson, we're going to be looking at the graphs of normal distributions. I hope you enjoyed today's lesson. Well, what does this z-value tell us? Remember that the z-value is simply the value you get minus your average divided by your standard deviation. That's going to help us convert to a standard normal curve, or a standard normal distribution. The probability that your z-value is less than a, I call this I of a. What's important to note here is that the z-value tells us the proportion, or the probability, or the percent of values less than a certain value. So if you're reading a z-value from a chart, it's always going to be this area to the left, or less than that value. What if you want to find the probability that your z-value is greater than a? Well, the charts and your calculator always give you the probability that z is less than some value of a. A is just some random number we picked. Well, to find the probability that z is greater, we have to do 1 minus the probability that z is less than a. This is the one, this red is the one you find in your charts or your calculator. 1 minus that will give you the blue, which would be the probability that it's greater than a. What if you were asked to find the probability that your z-value is less than negative a? Well, we would not find negative a values in our chart. We only have positive a values. But by symmetry, we can see values less than negative a will be the same as values greater than a. And in our last slide, we saw if we're trying to find z-values greater than a, that's simply 1 minus the I of a value, considering that I of a, in this case, would be everything to the left of a. 1 minus that would give you this area here, this red area here, which is the same as this area, which is ultimately what we're trying to find when we say, what's the probability that the z-value is less than negative a? And please don't forget, your z-value, again, you're just converting your x minus your average divided by your standard deviation. You're converting any normal curve to the standard normal curve. That's all you're doing. Remember, when we talk about z-values, we're talking about the probability that a random variable is less than our z-value. So if we want the probability that z is greater than negative a, first, we don't have greater thans with z-values. We always have less than, and we don't have negative a's. We always have a's. So the key is to use the symmetry of the standard normal curve to figure out how to get this red area. Well, the probability that z is greater than negative a is the same as the probability that z is less than a, which is that I of a. If you want to find the probability that z is greater than negative a, in other words, you want to find this, you have to use symmetry and say, well, that's going to be the same as the probability that z is less than a. Why is this one good? Because this is what the z-values are in your charts and tables and calculators. This is what they gave you. So if you want to find this, you have to relate this to this. And finally, with this standard normal distribution, our case 5 is find the probability that your z-value is between two values. Well, we want to know the probability that your z-value is less than b and less than a. So if I take all that is less than b minus all that is less than a, so the probability that the z-value is less than b, which is all of this down to negative infinity, minus the probability it's less than a, which starts here, I'll be left with this area in the middle.